Alright, here's an interesting variation of the problems we've been doing. Basically, the problem says find the standard form for the equation of a line that contains the point minus 5 minus 12 and is perpendicular to the equation of the line 2x plus 3y equals 12. Okay, well, we're going to use our old friend, the point slope formula, which looks like this. Retrieve from our vast database of mathematical formulas. We have to plug something into that. Alright, well, here's x1 and y1. That's pretty easy. But what's the slope? Well, we're given an equation, 2x plus 3y equals 12, and we're told that the slope we want is going to be perpendicular to this slope, or the slope of this line. Well, we don't know the slope of that line, so let's find the slope of that line, and then we'll deal with the perpendicular property in a bit. So how do I find the slope? Oh, I have to dig into my cheat sheet or my book or my vast reservoir of knowledge or cheat sheet or whatever. I'm starting to repeat myself, getting senile. To retrieve this, I'm sorry, I am getting senile, the slope point formula. Alright, that doesn't look like that, so we have to make it look like that by moving this over there. That's the first step. Not a problem. So what am I going to do? Let's copy it over. 2x plus 3y equals 12. Subtract 2x. Subtract 2x. No problem. That 0 goes away. It's 3y equals minus 2x plus 12. 3 is not 1, and this is a 1 here, so I got to divide both sides by 3. Okay, 3 divided by 3 is 1. 1 times y is just y. And this on the right-hand side becomes minus 2/3 x plus 12 over 3. Now we really don't have to simplify this, but what the heck. Y equals, well, I can't simplify this, 2/3 x plus 3 goes into 3 once, 3 goes into 12 4 times. So that's a 4. Alright, so the slope of that equation is this guy. Slope equals minus 2/3. But that's not the slope we're going to use. We want a slope that's perpendicular to this line. Alright, which is going to be perpendicular to this slope. Well, let's call this M1. Well, we know that M1 times M2 has to equal minus 1. Alright? So minus 2/3 times M2 has to equal minus 1. Okay, so what do we do? Well, I got to get rid of this. So I multiply it times its reciprocal, which is minus 3/2. And of course I have to do that to both sides. So that's going to be minus 3/2. Minus times a minus is plus. Alright, so we're going to get a plus. We don't need it, but we'll put it in there. 3 gets canceled by 3, that's a 1. 2 gets canceled by 2, that's a 1. So all that we're left with is M2. We have minus 1 times this. Minus times a plus is plus. So this becomes 3/2. Now, we could have done this a little quicker if we realized that the negative reciprocal of this just requires us to flip the fraction, all right, that's what a reciprocal is, and then take the negative part of it. So that was a negative, so it becomes negative negative, which becomes a plus. You could have done this either way. So now we go back and we plug that in. So our slope is now going to be 3/2. 3/2 x. What's x1? x1 is it's minus from here, and then a minus from here. That's 5. And that equals y minus, oops, yeah, y1, which is minus 12. Okay, it's a little messy. That's a plus, so we have y plus 12 equals, well, let's clean that up. That's x plus 5. Okie dokie. What are we going to do here? Well, I forgot what form. What form do we want? Find the standard form. Alright, that's another dip into our vast knowledge base of mathematical trivia. Alright, we have to make it look like that. Alright, first thing we're going to do is get rid of the parentheses. Good old PEMDAS. By distributing this guy. 3 halves times x is 3 halves times x. Duh! 3 halves times 5, a little more complicated. 3 halves, that's a 3. That's a 3 halves times 5 over 1. Okay, that equals 3 halves x plus 3 fives are 15, 2 ones are 2. And what do we have here? We have y plus 12. Alright, this x is on the wrong side, so we're going to subtract 3 halves x from here. And we're going to subtract 12 from here. And of course, oh, by the way, we've got to do that to both sides. So here's my minus 12 over here. And here's my minus 3 halves x over here. So I got minus 3 halves x over on that side. I have it on this side. Minus 12 over this side, minus 12 over that side. Sorry, just checking. I'm so prone to mistake that over the years I've become a double checker all the time. Oh, that's nice. That cancels. That cancels. I love to get rid of stuff. And I end up with minus 3 halves x plus y. Oh, dear oh me, oh my, oh mother. I got to do some arithmetic. So I've got 15 halves minus 12. Well, that's 12 over 1. And I'm going to multiply this by 2 over 2, which is just 1. And of course, I multiply by 1. Nothing has changed. I just changed this fraction into an equivalent fraction. So what do I get? I get 15 halves minus 2 times 12 is 24. 1 times 2 is 2. I have the same denominator, so I can proceed with my subtraction. 15 minus 24 is going to be minus 9 halves. So that equals minus 9 halves. All right. Now, if you've done that, you need to do this. You should do example 7. Example 7 is a little bit different. In here, the trick is that they want it parallel. So this basically means we need to find the slope of this. Well, the slope of that's a half. All right. So now that I know the slope and I know, this is x1, y1, I just plug that into my point slope intercept formula and I'm done. And that's on page 249. This one is, I think, yeah, exactly like the one we just did. And if you can do both of these, you'll do well in this course. I'm still Luke Kane, and I'll see you later. Bye now.